An event detection can be broadly defined as a sequence of activities performed by an object. For example, a man walking down the street or a child running can be defined as simple events. Event detection process involves both identifying the object under consideration and tracking it throughout the event. Event is detected by recording features of the object during its activity lifetime. Event tracking and detection are widely used processes exploited in many modern-day applications such as in traffic surveillance, visual monitoring, and abnormal event detection. Our main focus is to detect abnormal activities. So, what is an abnormal activity? Well, it is context-dependent. For different situations and different scenarios, what is defined as abnormal will change. In a given situation, what the majority does for a specific period of time is considered as a norm. For an example, in a one-way road, movement of vehicles in the given direction would be considered as the norm, and if a vehicle moves in the opposite direction, then it would be detected as an abnormal activity. In order to achieve the objectives of this project, following tasks were performed. Let's look at the first task. Formation of a video database. Videos were obtained for several scenarios as input data. The next one would be development of a robust foreground estimation technique. The detection of moving objects uses a background subtraction algorithm based on Gaussian mixture models. Finally, blob analysis detects group of connected pixels which are likely to correspond to moving objects. And then, the trajectories were generated using the centroids of the blobs that appear on the foreground video. Once the trajectories have been extracted, the next step is to compare them with each other and identify their disparities. Different features can be extracted using different distance matrices. For example, direction can be detected using dynamic time warping, and paths can be identified using average shortest squared distance matrix. This gives a very brief introduction on ASSD method. ASSD method introduced by us can be used to identify the trajectories on the same path despite the direction. Hence, it puts two trajectories on the same path but opposite in direction into the same class. The next task would be clustering patterns of activity and identifying anomalous events. Clustering could be defined as the process of grouping a set of objects based on their similarities. In the context of machine learning, what we are interested in is unsupervised learning. Today, different clustering methods such as k-means, spectral clustering, hierarchical clustering are available. The methodology used by us was spectral clustering. The specialty of this above others is that the number of clusters can also be identified using the algorithm itself. Giving a very brief introduction on spectral clustering, the word spectrum means the eigenvalues of a matrix. This method uses the spectrum of the similarity matrix of the data to perform dimensionally reduction before clustering in order to simplify the problem. For demonstration, consider the trajectories obtained in an ideal scenario of a junction of two roads. These trajectories are obtained for the case of people entering from the bottom road. Three cases are clearly identifiable: going straight, turning left, and turning right. The results obtained through spectral clustering is shown on the right. The fact that there are three distinct clusters is clearly visible in the cluster space. In the future, we will be focusing on noise removal of trajectories using adaptive filters, develop a robust shadow removal technique, develop distance matrix to capture other features such as speed and motion pattern, improving the clustering results through affinity aggregation, further analyze the variation of cluster modes with the variation of parameter sigma, develop an algorithm that can identify anomalies in a dynamic situation.